is an array? An array is a structured data type, meaning it's a collection of data arranged in a particular fashion in memory. By structured, it has to be a certain way, so each element in an array is contiguous, or one right after the other in RAM. So one element will be some address, the next one will be the following address. They're not going to be mixed up around in memory. So you need one big block to store everything. So an array is also homogeneous, meaning that all of its elements are of the same data type. Why learn about arrays? Arrays are a good entry point into learning about memory management and data structures. An array is a simple data structure that allows you to store and process a collection of data efficiently. For example, suppose you want to store the number of hours you worked each week for a year. This would require you to store 52 pieces of data. It would be tedious to create 52 variables for each week of the year, so instead you could simply declare an integer array of 52 elements. Then you could use some kind of loop to enter your information. What is a pointer? Arrays are also a good way to learn about pointers. A pointer is a special kind of variable for holding a memory address. Pointers allow you to access whatever information is being stored at that particular address. You can do this using a dereference operator, which looks like a multiplication symbol or asterisk in C++. The reference operator, on the other hand, looks like an AND symbol or ampersand, and is used to get the address of a variable. Here's a simple demo of what pointers can do. In this example, p is a pointer to some int variable. The data type of p is not int. Its data type is a pointer to an int. The star symbol means this is a pointer. So if you output the contents of p, you will get a memory address. Now let's declare an int variable called q. Q contains the value 23. We can use the reference operator to get the address of q. Pointers allow you to access data indirectly, so we can store the address of q in p by assigning ampersand q to p. Now p contains the address of q. We can now access the data being stored at that address indirectly using the dereference operator, the star symbol. Here's a quick illustration of what just happened. We assigned p to q by storing the address of q inside p using a reference operation. We were able to indirectly access the contents of q using the dereference operation. How are pointers and arrays related? Every time you declare an array, you are using a pointer. The name of the array is actually a pointer to the first element of the array. Here's a simple demonstration of this fact. Here we have a 3-element array of ints. Using the square brackets, or indexing operator, we can access the contents of a certain location of the array. At location 0 we have 1, at location 1 we have 5, and at location 2 we have 8. What do you think will happen if we output the contents of nums without the square brackets? Will we get all 3 numbers? Will we get 1 number? Will we get an address? Let's see. If you guessed that nums contains an address, you are correct. Since nums is the name of the array, it can be used as a pointer to the base of the array, or start of the array. If you increment the pointer, you can access the next element in the array. So let's set p to hold the address inside nums. Now p points to the same array as nums. Now we traverse down the array by incrementing the pointer p. We can access all the elements in the entire array using pointer arithmetic.